Question number 45. A man is sitting on the shore of a river. He is in the line of a 1 meter long boat and is 5.5 meters away from the center of the boat. This is situation of the boat. Center of the boat is here. Boat is 1 meter. It means this will be zero point 0.5 this distance and this distance will be zero point 0.5. And person, so this is center C, person is here at A. This total distance is 5.5 meter. It means suppose this point is D, so AD is 5 meters. So minimum horizontal range will be 5, just 5 meter, and maximum height horizontal range will be 5 plus length of the boat, 6. So we have to find out the angles of projection. Let's read it again. He wishes to throw an apple into the boat. If he can throw the apple only with a speed of 10 meters per second, find the minimum and maximum angles of projection for successful shot. Assume that the point of projection and the edge of the boat are in the same horizontal line. So one situation is like this, just here. And the second situation is like this, just at the end of the boat. So let's consider the first case. So horizontal range, this time we are taking as 5. So R equal to 5. And speed is given as U equal to 10 meters per second. Now we apply formula for horizontal range. R equal to U square sine 2 theta divided by G. So this will give R is 5 equal to U square 10 square into sine 2 theta divided by G. G is 10. So this will become sine 2 theta equal to, this is 100, this is 10, 5 by 10, that is 1 by 2. For sine 2 theta, it will be equal to sine 30 degree, from where we will get theta equal to 15 degree. So one angle is 15 degree, and we know for same horizontal range, there are two angles of projection. One is theta, another is 90 minus theta. So another angle corresponding to this will be, suppose this is theta 1. So theta 2 will be 90 minus theta, 90 minus 15 is 75. Now consider when horizontal range is 6 meters. So R is 6 meters. Again, we apply formula 6 equal to 10 square sine 2 theta divided by 10. So from where we get sine 2 theta equal to 110 will consider 3 by 5. Now, if we draw a triangle for this Pythagorean triangle, this is 3, this is 5, then theta will be equal to, this will give theta as 37 degree. Now, this 2 theta equal to 37 degree or theta equal to 18.5 degree. Now again, same rule. For same horizontal range, there are two angles. So another will be 90 minus theta. So suppose this is theta 3. Now theta 4 will be 90 minus 18.5. And that will be equal to 71.5. Now we have got four angles, 15 degree, 75 degree, 18.5 degree, and 71.5 degree. And our question is, we have to find out the least and the maximum angles. So least angle is 15 degree and maximum angle will be 75 degree. Now let's go to next question. Next question says, a river 400 meter wide is flowing at the rate of 2 meters per second. A boat is sailing at a velocity of 10 meters per second with respect to the water in a direction perpendicular to the river. Find the time taken by the person to reach the opposite bank. How far from the point directly opposite to its starting point does the boat reach? So situation is like this. This is direction of river flow, and this is directly opposite point. Suppose boat starts from here, and this is point B. So boat reaches somewhere here. C. So we have to find out time taken to cross the river and BC. So time taken can be directly found. T will be width of the river 400 meters and the speed of the boat is 10 meters per second. So this will give 40 seconds. Now BC will be time into speed of river, V river. So time is 40, speed of river is 2 meters per second. So this will be 80 meters. Now, next question. But before that, you have to care about it. Physics classes are available online or offline. The classes are for JEE, NEET, CBSE, ICSC. You can contact at 9958912423. Question number 47. A swimmer wishes to cross 500-meter wide river flowing at rate of 5 kilometers per hour. This is 500 meter and speed of river is 5 kilometers per hour. Its speed with respect to water is 3 kilometers per hour. And suppose man moves in this direction like this with 3 kilometers per hour. So we have to write its components. Suppose this is 3 kilometers per hour. And in our question, man makes angle theta with the river flow. Suppose flow direction is this. So this suppose this angle is theta. So due to 3 cos theta components, he will move in this direction. And due to 3 sin theta component, he will try to cross the river. So time taken to cross the river equal to width of the river, that is 500 meter means 0.5 kilometer divided by speed in this direction will be 3 sin theta. Now we can write it 5 by 10 into 3 sin theta. So this will become 1 by 6 sin theta, and this time is in hour. Now, if we want to convert it into minutes, so we can do one thing, we can multiply by 60 divided by 6 sin theta minutes, which will be equal to 10 upon sin theta minutes. Now, suppose we want to find out shortest time. So for shortest time, sin theta will be 1. That is theta. When theta equal to 90 degrees, sin theta will become 1. And then shortest time, the shortest will be equal to 10 minutes. Now, next question. Consider the situation of the previous problem. The problem is same as mentioned already. So here, this speed is given as 5 kilometers per hour and river is 0.5 kilometer. Now, question says the man has to reach the other shore at the point directly opposite to his starting point. Man starts from here and he wants to reach to point B. If he reaches the other shore somewhere else, suppose he reaches here at this point, point C, then he has to walk down to the point. Find the minimum distance that he has to walk. So let's evaluate it. The time taken Here again, this speed is 3 kilometer per hour and this angle is theta. So time taken, as we have already calculated in previous problem, it will be equal to 0.5 divided by speed 3 sine theta. Now, during this time, horizontal distance covered. So, suppose this distance is x. So, x equal to speed into time. Speed in this direction will be speed of the river plus 3 cos theta. So, 3 cos theta plus 5 times time. Time is, we can write it as 1 upon 6 sine theta, as we have done in previous problem. 1 upon 6 sine theta. Now, we have to minimize the distance. For that purpose, we have to differentiate it with respect to theta, dx upon d theta. We apply quotient rule, 6 sine theta times derivative of this minus 3 sine theta minus this will become 3 cos theta plus 5 times derivative of 6 sine theta. So 6 cos theta whole divided by denominator square, that is 36 sine square theta. Now we open the bracket. This will become minus 18 sine square theta minus 18 cos square theta minus 30 cos theta equal to divided by 36 sine square theta. For maximum or minimum, dx upon d theta must be 0. So from where we get 18 negative minus 30 cos theta equals 0, or cos theta equals minus 2 by 5. So it will become not 2 by 5, sorry, it should be 6 3 are 6 5. So 3 by 5. Since cos theta is negative, it means this is obtuse angle. So direction should be somewhere like this. This is the angle from this point. Now, for obtuse angle, cos theta is negative, but sine theta will be positive. So we draw triangle. We write here 3, 5. So this will be 4. This theta. So sine theta will be 4 upon 5. Now our concern is to get distance. So let's evaluate this line. So distance h equal to 3 cos theta plus 5 divided by 6 sine theta, which is equal to 3 into cos theta we have got as minus 3 by 5 and plus 5 whole divided by 6 times sine theta is 4 by 5. This will become minus 9 plus 25 divided by 5 into 24 upon 5. 5 cancel out. This will become 16 by 24, which is 2 by 3 kilometers. And that is our answer. Thank you for watching.